Going live. There, I'm live. Excellent. The one person waiting for me right there. There we go. So, do you guys remember in September when I made a big deal about the benchmark that you guys had to take? This is where you all nod yes. There you go. Good. And do you remember, did I complain to you about that benchmark? Did I complain? Yes, there you are nodding yes for that one. Good. So in September, to give you a reminder, we had to give you a benchmark. And our supervisor was like, give them this benchmark. And then we looked over, the math teachers, we looked over the benchmark. We're like, but the benchmark, it's not on the information we have to give them. Yes, it is. Give them the benchmark. No, you want us to give them a benchmark on material that they learned last year in geometry, not the stuff that they're supposed to learn by the end of Algebra 2. Give them that benchmark. Fine, we'll give them the benchmark, but it's the wrong one. And then 2 weeks later, we get an email saying, oops, it was the wrong one. Thus, if you've seen Google Classroom, we have to take the real benchmark now. Oh, I know you're so excited. And it still doesn't count against you. Mr. Markey, why do we have to take it? Because crap rolls downhill. Is that fair? Just say, crap rolls downhill. So you have a benchmark on geometry information. Just read the directions on what I've set aside for it. It's like what I said, set aside like an hour or so. And just knock that thing out to the best of your ability, even though it doesn't count against you. Mr. Markey, it's a waste of time. Shut up. But this is where we're at. So let's see where we're going with this. We are about to wrap up the unit on quadratics. I plan on taking a major assessment to wrap up the unit on quadratics next week. We're going to figure out how we're going to take that, usually online or blah, 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 stuff like that. We'll deal with that next week. This week, I would like to wrap up the chapter on quadratics. Now, part of what I'm going to do, I'm going to put into your notes, but I'm not ready for your notes just yet. So just wait a minute. Instead, I want to wrap up using this worksheet. Now, for those of you in the live stream, this worksheet should be a PDF that was submitted to the Google Classroom stream. Just double checking that right now. I'm pretty confident that it's there. I moved it up to the top. It says Algebra 2 CP Quadratic Formula Review, and it's a PDF file. So if you need the online version, it's there. But for those of you in class, congratulations. You get a paper copy. This is what I'm going to be focusing on today. Now, this is going to be a little intensive. The reason why it's going to be a little intensive is just because you're going to be looking at some of these problems and being like, what in the heck is going on? How in the world do you expect me to answer a question that has a lot of words in it? Like, Mr. Markey, you know how I feel about word problems. I know how you feel about word problems. I'm here to get you over that fear. I'm here to train you in such a way in order to properly interpret how to gauge these problems and how to attack these problems. That is the purpose of today. Now, yes, like I said, we are going to add information into our notes eventually. I'll let you know when that time comes. But in the meantime, just adjusting the camera here. There we go. In the meantime, let's look at this worksheet. And again, for those of you in the live stream, open up that PDF and you can put a lot of this stuff on a separate piece of paper. That's onto you. So let's see here. Let me close out that. Open that up. Flip that. There we go. And there we are. Why is it frozen? Like my heart. There we go. Good. Let me zoom in right here. We're going to spend a lot of time on this worksheet today. You're going to see all the information that I write down on this worksheet is going to be gold. You and your friend are playing tennis. I don't know. Your friend lobs the ball into the air, hitting it 3 feet above the court with an initial velocity of 40 feet per second. You back up and prepare to hit an overhead smash to win the point. Now, I don't play tennis. I understand the rules of tennis. I know some of the statistics behind tennis, but I don't play tennis, so I'm not really familiar with some of the technical aspects of it. But what I do understand is that you hit the ball in the air over the net, and then you hit it back and forth until somebody messes up. So here's where we're at. Let me draw a picture. Even if you don't understand anything about tennis, you can recognize some of the stuff that they're trying to tell you. At the top of your page, draw the following. Draw a little XY axis action going on up there. I'm going to put a little dot here, and I'm going to write 3 feet. That is the height at which your friend hits the ball. Now, again, he's hitting it 3 feet above the court. Again, proper interpretation of this. Again, I don't understand much about tennis, but if he's hitting it like 3 feet above the court, 3 feet's like about right here-ish, something along those lines, which means he's probably bouncing the ball or just holding the ball and then dropping it and then going boom like that. And that's the noise that he makes. He hits the ball like that, probably 3 feet above the ground, hitting it over to where I am standing. So I'm going to display that image of the ball flying through the air with a little bit of a dotted line action. This is not to scale, but I'm just going to try my best to kind of display that. And you can see the parabola path that the ball is taking all the way to where I am standing in my stick figure glory, where I am holding my tennis racket. I don't know how to draw a tennis racket, so I'm just going to draw this because I think that's kind of how a tennis racket looks, I guess. There's me holding the tennis racket, about to smash it back at him because I want to win. And screw him, I get to win, not him. Give myself some eyebrows and a mouth and some hair. My hair's not that long. And a beard. There we go, good. You can give me a beard as well, that's up to you. So now, this is the scenario that we have. Your friend and you are playing tennis. Your friend lobs the ball into the air, hitting it 3 feet above the court. This is the path of the ball. Forget about initial velocity. Forget about that for a moment. This is the scenario that we're faced with. It's a parabola. We have a lot of tools at our disposal. There are some tools that you don't have that I'm going to share with you today. Let's look at part A. Use the model h equals -16t squared plus v sub 0t plus h sub 0, where v sub 0 is the initial velocity and h sub 0 is the initial height, to write an equation giving the height of the lob tennis ball as a function of time. Okay, it's a lot of words. It's a lot of words that I guarantee most of you probably weren't even listening to. It's what happens. You read a problem and you're like, oh, and then you just stop, and your brain just stops. Let's get into this. V sub 0 is just a fancy little variable. And they're just saying that that is the initial velocity. They tell me the initial velocity, 40 feet per second. Initial velocity, 40 feet per second. I'm just going to underline that. Initial velocity. And I also need the initial height. Now, the initial height is just, well, how high is the ball when it starts moving? And clearly, that's 3 feet. The answer to part A that I am looking at is something along these lines. H equals -16t squared plus 40t plus 3. That's where we're at. Again, I like that little cute tail at the bottom of my T, so I don't mix it up with plus signs. Now, this is not the only way that you could write this. This is the answer, by the way, to part A, but it's not the only way you could write this. Let me zoom in a little more. The other way that you could potentially write this is using a little bit of function notation. We'll plug something in a moment to kind of talk about this a little bit deeper. When I say the words function notation, despite the headache that you have when you hear it, you should be thinking about f of x. Now, I don't see an f up here and I don't see an x up here, but f of x is the typical function notation that you are used to. I'm writing h of t. It's the same concept, just with different letters. H of t is the height as a function of t, meaning depending on how much time goes by, the ball is going to be at a different height. For example, what is the initial height of the ball? One more time. 3 feet. How much time has gone by when we're at that spot? How much time has gone by if we are at the initial height of the ball at 3 feet? 0 what? 0 seconds. Again, we need to recognize t is indeed measured in seconds and h is measured in feet. Yes, that's going to be a constant for this particular problem. But if you are at 0 seconds, meaning you'd plug a 0 in for that t, there it is. You plug a 0 in right here, a 0 there, a 0 there, a 0 there. It would eventually say that h of 0, or h at 0 seconds, is equal to 3. You can plug in any number you want. You can plug in a 1, you can plug in a 10, it doesn't matter. It'll give you the height of the ball. Now, obviously, there's real-life implications here. Obviously, if you've ever watched somebody play tennis and you hit the ball, clearly that ball's not going to be in the air for 10 seconds. Approximately how long does it take for a ball to go across like a tennis court if it's hit pretty hard? What would you guess? You ever watch tennis? Oh, gosh, the tournaments, it's amazing. You know how many people participate in a major tournament for tennis? 128 people. You know why it's 128? Because it's a power of 2. Math. But anyway, back to this. It takes a second or 2, fractions of seconds, for the ball to go across the court. It's pretty crazy. But this is the function that we're going to be dealing with. Either one, I need you to be familiar with. Let's look at part B. Now, if I'm looking at part B, now all of a sudden we're getting into something that we're not as familiar with. What is the average rate of change? What the heck is that? Think back to Algebra 1. Algebra 1? Oh my goodness. What did you mainly focus on in Algebra 1? What type of math problem? I haven't taught Algebra 1 in a very long time. It's been quite a minute. I don't know. What kind of graphs were you drawing in Algebra 1? Were you just trying to bide your time and hope that the teacher didn't notice? That you were drawing cubes the whole time? You ever just draw cubes in class over and over again? Nobody wants to admit it. What did you draw in Algebra 1? What did you really draw? What did you graph? What did you write equations of? Ooh. Oh, no one wants to say it. You know it, but you don't want to say it. Average rate of change is slope. Average rate of change is slope. Slope deals with linear equations. Linear. It's funny. Anyway, back to this. When I say slope, and I'm talking average rate of change, there is a certain formula that should pop into your head. Again, I don't know who taught you Algebra 1. I have no idea. I don't know how good of a job they did. I don't know how bad of a job they did. This is over 2 years ago that you took Algebra 1. Gosh. But what you should remember, or what should look familiar, is this. Now, the question you should be asking yourself is, why is he showing us linear when this whole thing is about quadratics? It's because of the question. The question says, what is the average rate of change? Now, again, these questions are not going to be fair. They're not going to be fair. The questions that are going to be thrown at you are going to be questions where you have to properly interpret what it's asking and then determining whether or not you have the tools to answer it. That is how we calculate slope. Goodness. All right, I haven't even read the whole question. What is the average rate of change of the height over the first 2 seconds after the ball was hit? Now, you already told me one of those answers. You told me when it's 3 feet in the air, that's 0 seconds. So that's actually something that's going to be incredibly helpful, because I need the average rate of change over the first 2 seconds. Rate of change implies slope. That equation tells me I need 2 ordered pairs. The first ordered pair is 0, 3. Because I'm talking about the first 2 seconds, meaning the moment that the ball is hit, when 0 seconds have gone by, up to the point where it has passed 2 seconds in the air. And if I have that ending point of 2 seconds, comma, whatever feet, then I can plug and chug and get my answer. Ooh. How high is the ball after 2 seconds? I have a tennis ball, I think. Hold on. I think I have a tennis ball in here somewhere. I thought I did. Oh, yeah, I do. Miss Margie, why do you have a tennis ball? Shut up. I can have what I want. I could use a lacrosse ball. You know how hard those things are? It's insane. Does nobody know how hard a lacrosse ball is? Oh, really? Crazy. Hold on. I got random stuff in here. Hold on. There it is. I was looking at a baseball for some reason. I don't know why. And a tape ball. But anyway, so like, listen. Here's a tennis ball. Ready? Listen. That's just a tennis ball. Here's a baseball. That's baseball. Here's a lacrosse ball. You hear the density? Oh, it's so sick. Who's below me? Whose classroom is down there? Nice. Anyway, I hope his teacher. Anyway, so this ball, it's like I hit it, and it goes like, okay, here's 0 seconds, and here's 3 feet, right? And then, who was that? Anyway, back to there. What's the height of the ball after 2 seconds? How do I figure that out? Oh, no. Oh, no. How do you determine the height of the ball after 2 seconds? I guess I could just guess. Nope. I don't want to guess. How do I use part A to get that answer? How do I use part A in order to figure out the height of the ball after 2 seconds? Feel that. It's pretty intense, right? Yeah. Anyway. No one wants to say it. Oh, no. Everyone's got stage fright. Or they don't want me to throw the ball at their head. I don't even know where I got this from. Oh, you're all leaving me hanging out to dry. Check this out. How do I determine this number? Mr. Markey, too much time has gone by. And now if anybody says anything, it's going to be incredibly awkward. I know, right? Ugh, you're killing me, Smalls. Anyway, what if I told you it was 19 feet? Mr. Markey, how'd you get that? I don't know. How did I get that? But it is 19 feet. Ladies and gentlemen, you want to figure out the height of the ball at any given time, you just simply have to plug in the number into the equation. You plug in the number for t. If you know the time that you want, take that value, that numerical value, and plug it in for t. So for example, I wanted to find 2 seconds. It's just a matter of plugging in 2 into the appropriate location. And then just following whatever the calculator says, as long as you type it in correctly. And then the proper order of operations. So this would be like what? Negative 16 times 4 plus 80 plus 3. This would be negative 64 plus 83, which if you did that correctly is 19. 19 feet in the air. Then it's just a plug and chug situation. I wish I had a tennis racket. I'm just throwing that out there. 19 minus 3. Which remind me, what are those numbers measured in? What are the units on those numbers? Feet. And then 3 minus 0. There's a reason why I'm asking this. 3 minus 0, what are the units on there? What are those measured in, those numbers on the bottom? Seconds. This would give me, what is that, 16? Oh, I'm sorry, I wrote a 3. Why did I write a 3? What should it be? Yeah, it should be a 2. Where's my head? I don't even know. This gives me 8. Now, I asked you about the top, that you said the top numbers were measured in feet. You told me the bottom numbers were measured in seconds. Yes, 8 feet per second. A rate of change. A rate is typically some form of speed or velocity, something along those lines. Over the course of the first 2 seconds, the ball has moved an average of 8 feet per second in height. I'm not talking about horizontal distance, I'm just talking about height. Approximately 8 feet per second. So this ball starts at 3, bam! And then it travels 8 feet per second on a vertical basis. And then the question becomes, will the ball ever reach a height of 30 feet? And then they ask why. We have not talked about this. We have not talked about this, but let me go back over here to this picture real quick. I'm going to have you add a little bit more to this picture. First of all, this axis is measured in feet. This axis is measured in seconds. And the question is, will the ball ever reach a height of 30 feet? I'm going to write this very carefully. This point right up top is called the vertex. Now, we haven't talked about this. Mainly when we've talked about quadratics, we have talked about factoring them and solving them and quadratic formulating them and word problems and setting up pictures and things of that nature. We've been doing all of that. But now I got to talk about the vertex. Did you know that I can't juggle? I can't juggle that well. Ready? Hold on. That was actually really good. My gosh. I impressed myself. Guess what I just learned? I learned how to juggle. Anyway, the vertex. The vertex is the extreme point. The vertex is either going to be the highest or the lowest point on your parabola. And in this case, we need to find out where the vertex is. Because if we know where the vertex is, then we will know the answer to that question. Will the ball ever reach a height of 30 feet? Now, at the moment, I have absolutely no idea. But I have not given you this tool. Let me give you this tool. Next to part C, write the following. Next to part C, right here, write the following. The vertex is equal to this formula. More specifically, it only gives you the x value of that vertex. That looks familiar. Why does that look familiar? Negative b over 2a. Why does that feel familiar? Where have I seen that before? Oh my gosh, except it's missing something. He says it's in the quadratic formula, but I know it's missing something. What's it missing? You know what's missing? The square root plus or minus the square root b squared minus 4ac. It's missing that. That's interesting. I wonder if there's a reason for that. Oh, well, we'll come back to it. But that's what we need. I need negative b over 2a. If you go back to the equation that you wrote down in part A, this is a x squared, even though it's a t, ax squared plus bx plus c. I have the values that I need to get this thing done. Equals negative b over 2 times a. Be very careful with how you're calculating this. This should actually be negative 40 over negative 32, which if you did this correctly, should give you a positive 1.25. Positive 1.25 what? A Positive 1.25 what? Ugh. I calculated something, but I need to know what it is that I've just calculated. Ugh. I don't know. It's the x value of the vertex. What did I label my x-axis as? What's it measured in? Come on, what's it measured in? No one wants to say it. 1.25, comma something that I don't know what that something is just yet, but it's 1.25 seconds. After 1.25 seconds, the ball will reach the highest point. But that doesn't answer the question to part C. That does not answer the question to part C. 1.25 seconds is only half of what I need. I have the time it takes to reach its highest point, but I still don't know what the highest point is. Take that 1.25, plug it into the equation for t. What will this give me? Not the number, but like in words. If I do this correctly and it spits out a number, what does that number represent? Yeah, the highest that the ball will reach. Oh, I gotta zoom out. There we go. If I take that 1.25 and I plug it back into that equation, the height that it'll give me is the highest point that it will reach, the highest height. Every problem that you see on this page, you're gonna have to do something slightly different depending on what they're asking. Now, if you did this correctly, it should spit out 28. More specifically, it's 28 feet. Now you can ask that question. Will the ball ever reach a height of 30 feet? No. Maximum is 28 feet. You have to give a justification. You have to give a mathematical justification behind it. The reason why high school students typically hate word problems because they're just so confused as to what the heck the question is even asking, number one. Number two, they don't even know how to start the problem. My thought is that the reason why high school students typically hate word problems is because they're unwilling to deep dive and actually read what it's asking. They skim the words and they hope beyond hope that by skimming the words and looking at the numbers, they'll be able to just, the answer will just pop out to them and it'll be obvious. No, that is not how this works. Every problem is different. You have the tools to attack these problems. My job is to help you know how and when to use these tools and have the practice with these tools. You can cross out part D. That was an accident. I don't know why I wrote that question. I wrote the question twice, basically. I wrote the same question twice. I just wrote it in different words. So I'm just going to cross out part D with a flourish. There's the flourish. But now I come to part E. Now I come to part E, because this is the main question of the day. If you plan to smash the ball when it falls to a height of 8 feet above the court, how long do you have to prepare for the shot? If you plan to smash the ball 8 feet above the court, how long do you have to prepare for the shot? Let me go back to my picture. Yay. Let me zoom in a little bit. Let me put a little note right here. This right here, that is 8 feet above the court. I'm just going to put a little thing up there. There we go. Now, I want you to notice something here. I want you to notice something. Every parabola is symmetric. 1.25 seconds to get up to here. And after an additional 1.25, wait a minute. Where will the ball be at 2.5 seconds? You can guess this with no calculations whatsoever. How high will the ball be from the ground, or how far will the ball be from the ground at 2.5 seconds? If every parabola is symmetric. Let's say this point is 2.5 comma something, question mark. What's the height of that question mark? You can get it with no calculations, just logic. Ooh. I think my beard's in the way in the picture. You should have seen me during the summer. My beard was like down to here. That's fantastic. Come on, geometry students. You all took geometry last year, correct? Or the year before, whatever. Y'all love geometry. You remember how much you love geometry? Whatever. Shut up. Parabolas are symmetric. They're reflexive. They're mirror images on either side of that vertex. If it takes me 1.25 seconds to get up here and 1.25 seconds to get to this point right here, how high off the ground am I? Let's take a guess. Give me a number. 3 feet. Yeah, it's 3 feet because of the symmetry behind this whole thing. Now, that's not the question they're asking. That's clearly not the question they're asking, but I'm trying to give some justification behind visualizing what is going on with this parabola. Everything is symmetric. Everything is symmetric. Now, if this is 3 feet off the ground, clearly this is not my answer to the 8 feet question. This is 1.25 seconds at the vertex. This is 2.5 seconds at 3 feet over here. My answer clearly has to be between the two. But where? I guess we got to dive a little bit deeper into this problem. Because again, I'm trying to get you to this logical point of knowing what to do when this question is placed in front of you. You plan to smash the ball at a height of 8 feet above the court. How long do you have to prepare? 8 feet is the height, and the question is how long, that's the T. The only other piece of information that may be of help is this. This is the path of the ball, this equation. This equation represents the path of the ball. They want me to figure out what T is when the height of the ball is 8 feet. This is what we're faced with. This is what we're faced with. If I could solve for T, I can figure out precisely how much time I have. I'm going to do a little moving around of stuff. Notice what I just did. Something that you have done over and over and over again when it came to solving quadratics. Get one side equal to 0. You plan to smash the ball when it falls to a height of 8 feet above the court. How long? What is the value of T? That is the time that you have to prepare for the shot. This is what we have to solve. Now, spoiler, it's not factorable. You cannot factor that. It will not factor. It won't. So instead, write this off to the side. Something that you've seen over and over and over again is the quadratic formula. Hopefully by this point, you can't see the whole of it. There it is. Hopefully at this point you do have a grasp as to how to use that formula, how to memorize that formula, how to recreate that formula, things of that nature. But now we're going to utilize it for this particular problem. I am going to calculate my discriminant, which is b squared minus 4ac. I need you to be very careful there. I'm going to show you something in the calculator in a moment. But I need you to be extremely careful when it comes to typing that into the calculator. Let me actually type that in now, and then I'll zoom in on my calculator. There we go. Zooming in, zooming in, zooming in, zooming in. Be very careful on the graphing calculator, ladies and gentlemen. Please be very careful, because there is a big difference between the minus sign and the negative sign. I need you to be careful. I need you to be extremely careful, because if you type this in wrong, how about this? How about this? When you type something into the calculator and it gives you a number, do you just not question it and just write down whatever the calculator says? Several people nodding yes. Because you trust the calculator. I don't trust the calculator as far as I can throw it, which is not that far. Don't trust the calculator. Trust yourself typing it in. That actually is the answer right there. I'm sorry, not the answer, but the discriminant. That is the value of the discriminant. Don't trust the calculator because you're the one using it. You type it in wrong, the calculator is just going to give you the wrong answer. Be careful, be careful, be careful. Get that practice in. This is 1280. Which tells me there's going to be two answers, but let's just see what happens. Negative b plus or minus the square root of the discriminant, the whole thing over 2 times a. Now I'm going to break this thing down piece by piece, and then I'm going to make a big deal about something. But when have I not made a big deal about something? This is really negative 40 plus or minus the square root of 1280, the whole thing over negative 32. Now, if we were living in the world of last week, I would say, hey, let's try to simplify this thing down, blah, 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 blah. But we're not living in last week. We're living in a word problem. We're living in a word problem where it doesn't really make much sense to say negative 40 plus or minus square root of 1280 over negative 32 seconds. That doesn't make any sense to me. We're living in a word problem. And since we're living in a word problem, this is not going to be acceptable. We have to get the decimal. Now, I'm not asking for anyone to open up the Chromebooks or anything like that. Don't worry about that right now. Don't worry about that, because I was going to say with the graphing calculator, I was going to show you what to do. Side note, anybody use an Android? You do? Are you the only one? Congratulations. You can download the app Wabbit Emu. Do you know what Wabbit with a W, Wabbit Emu is? Check this out. This is my Android phone. It is a Samsung Galaxy 7, I think, or something like that. That's my phone. It's a fully functioning TI-84 plus calculator on the phone. You can only get it on an Android. If you have an Apple phone, you suck, because these are better. Look, it works. Everything is there. It's so phenomenal. But anyway, I digress. I was going to show you how to type this thing in 2 different ways, because the calculators do have like slightly different ways of doing it. So if I was typing this thing in, negative 40 plus the square root of 1280. Now notice in the 83 calculator, it does the little parenthesis. Now you guys on your Chromebooks, you have the 84s? Cool. If you have the 84s, it does something slightly different. I closed that parenthesis. It only closes it around the square root. I close it again. It closes it around the top of the fraction divided by negative 32. Now I'll hit enter in a moment. But now look at the Samsung Galaxy phone that's better than yours. Parentheses, negative 40 plus square root. Now notice when I open that square root, all of a sudden it didn't open a parenthesis. I need you to be aware of that because you need to know how to type these things in correctly. If I hit 1280, it has the little arrow key, typing to the right, and then I close the parenthesis. Now, closing that parenthesis closes it around the top of the fraction, divided by -32. Now, again, I'm not hitting enter just yet. I just need you to see this. Just notice the difference between the two. This is the 84, and this is what you have on the Chromebooks. So if you do try to type this thing in on the Chromebooks, I just need you to be aware of that fact. If you're typing in on an 83 calculator, then it'll open up a parenthesis, and then you'll have to close it double. If you type this in wrong, it will give you the wrong answer. But that is one of the answers that we get. You want to know a secret about the calculator? I have to type in plus or minus. I have to do this calculation with -40 plus and -40 minus. Here's the secret. There it is, minus. I didn't have to type the whole thing back in. Have you guys ever had to do that where you type a whole long thing in, then you screw it up and you just clear the whole thing out? You don't have to do that. Watch this, I'll do it over here. What did I hit? Do you know what I hit? Good. It's a secret. No, I'll tell you. It's second enter. Second enter. If you hit second enter, it brings back the most recent calculation that you just did. And it allows you to edit what's on the inside of it. So I can change that plus to a minus and I get my other answer. I just wanted you to be aware of that. Second enter is an incredibly helpful tool when it comes to the graphing calculator. Sweet. Now, I got two answers here. Oh, crap, they're both positive. Oh, goodness, great. Let me write these down. Hold on. Let me write these down. I got an answer of 0.132 seconds. And then I get an answer of 2.37 seconds. Oh, man. Which one is correct? Which one's correct? Ooh, why? I agree with you. For that's 2.37. And what do you mean it's going to the other person? Exactly. No, I agree with you wholeheartedly. The vertex is 1.25. That's 1.25 seconds. And clearly it's going to you on the other side of the court. It's got to be the 2.37. It's got to be the 2.37. So where did this other number come from? Where did this other number of 0.132 come from? Where did that other number come from? Let me go to I'll leave that there. I'm going to come to the board real quick. I agree with you. Right here, this is 2.37 seconds, and that is the answer to that last question. Where did the other number come from? Why is the other number there? It's a positive number. It's a legitimate number. What was that number? Is that 0.132? 0.132 seconds. The ball goes up to 8 feet on the way up, goes all the way to the vertex, and then comes back down to a height of 8 feet, and that's when you hit it. The reason why both answers pop up is because of the symmetry that is in a parabola. It's because of the symmetry that you have in this parabola. This is also 8 feet. It has to hit 8 feet twice, once on the way up, once on the way down. You're right, it is 2.37, and your logic is sound, because it had to be after 1.25 seconds. It had to be after the vertex. I'm just trying to get you guys to realize both answers are legitimate. It's just that the second one's correct, because in real life, in the context of the situation, you would have to wait for the ball to come to you, and then you hit it at a height of 8 feet. Ah, I love it. Math is weird. Do. Most of my pictures are going to be stick men with beards, just so you know. Just be prepared. Sometimes I'll put tears on them. That's me crying on the inside, crying for attention. Okay. Here's what I want. I have several things to show you that I need you to put in a safe location. So if you would, ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Here we go. And there we go. Oh, that's a lot of noise. That over there. There we go. I don't know how far Miss Betty got in your class. Was she around this point of like quadratic formula? Yeah. All right, cool. Because I know that she spent some more time on like completing the square and whatnot. Okay. Did you like completing the square? Okay. I love completing the square. Anyway, completing the square is how they derived the quadratic formula in the first place. Did she show you that? Okay, that's fine. It's fine. It's one of the most amazing derivations of a formula in the history of mathematics, because you take ax squared plus bx plus c, which we're all familiar with. We all should be familiar with ax squared plus bx plus c. And they take that and they very logically turn it into the quadratic formula. It's one of the most amazing things of all time. You want to see it? I'm so excited. No one else said yes. So you don't have to write this down. I just want you to see it. It's the craziest thing of all time, where they take ax squared plus bx plus c, set it equal to 0. They take a out of the first thing right here, which is b over ax, and then leave a blank right here and put it as negative c or something like that. Just kind of leave it over there. Then they divide that by 2 and they square it. And they're like, okay, well, we have to put in something here in order to complete the square. So they put in like b squared over 4a squared or something like that, which is a little weird. But in order to keep it balanced, they have to add the same thing to the other side, which is also being multiplied by a. So they're actually adding a b squared over 4a, which is, again, like, what is going on? Then they take this and they do this and they do like it as 2a like that, squared equals. And they do a little common denominator thing there. So they go like a negative 4ac over 4a and then a plus and a b squared over a and some weird thing like that. It's like, okay, this is just getting weird. Then they have to divide both sides by a, so they get the b over 2a and squared equals that. And then they bring these two together. Well, they have, yeah. Oh, and there's the 4 right there, so they have the common denominator. Good. They have to divide by a, so this whole thing ends up being b squared minus 4ac over 4a squared. Good. Then they have to square root both sides, and they square root both sides. That equals plus or minus the square root around this whole thing, b squared minus 4ac over 4a squared. It just so happens the 4 and the a squared are both perfect squares, so they can become like a 2a. So it becomes a to b over 2a equals plus or minus the square root of b squared minus 4ac, the whole thing over 2a. Then they have to subtract that thing over, and it's a common denominator already with the 2a, and they end up with the quadratic formula. It's the craziest thing in the world. Yeah. Did y'all get that? It's perfect, right? That was great. I know. It's just amazing. Math is crazy. There's an amazing historical story behind not the quadratic formula, but the cubic formula. But I'll save that for another day. P.S. I'm never going to show you the cubic formula. Oh, the cubic formula. Can't wait. Anyway.
Wait, why are you never going to show it?
Because of the following. In the next unit that we are getting to, we're getting to higher level polynomials. We're getting to cubics and quartics and quintics. All we've done so far is quadratics, which are second degree polynomials. But we're going to be getting to third and fourth and fifth degree polynomials, where I'm going to show you how to properly factor those using a method called synthetic division. Okay. But if you have a cubic that can't be factored, in Algebra 2, they will not expect you to solve it. They will not expect you to solve it. If they did, then you would have to know the cubic formula. Now, you know what the quadratic formula is, but the cubic formula looks like that. And I'm not teaching that.
Oh wait, that's one whole.
Yeah, that's one whole part of it. The rest of it's down here. But back to this. Today is the 20th. I could use a cup of coffee. Anyway, I haven't drunk any today. Whatever. Coffee calms me down. Now, I wrote this on our paper before on the worksheet, the x value of the vertex, but I wanted to make sure that you had this here. The x value of the vertex is negative b over 2a. It is very similar to, as we talked about, the quad formula. It's very similar to the quad formula. The quad formula being negative b plus or minus the square root b squared minus 4ac, the whole thing over 2a. Now, I want to talk very briefly about why that is. These two formulas look exactly the same, except, the marker go, there it is, except this portion of it has gone away. That portion of it is just poof, gone. And there is one instance in which that portion of the quad formula would actually disappear. And it's if that portion of the formula were equal to 0. One might ask the question, well, how do you get that equal to 0? It would really be like negative b plus or minus 0 over 2a, which would then just be the vertex formula. If your discriminant, now this is going back 2 weeks now. This is going back 2 weeks. If your discriminant is equal to 0, how many real solutions do you have? Just have one. How does that look? If I were to graph it, what would that look like? If you had a parabola with just one real solution, what would it look like on the graph? Ooh. Ooh. It would look something like that, where the solution and the vertex happen to be the same thing. It's a little strange, little conundrum there, but everything works together perfectly. If your discriminant is equal to 0, then all that you're left with is the vertex formula. It's really phenomenal the way that thing works out. People in the administration are just outside the door. They think I don't know that they're there, but I know they're there. He's just standing there watching for me to make a mistake so he can find the clues to the treasure. He will never find them. You know what he teaches? He teaches English. English, it's a made-up language. My wife has an English degree. I constantly make fun of her for it. This is something, no, I really don't. My wife is to be completely honest, my wife is 1,000 times smarter than I am. She really is. My wife has 2 bachelor's degrees, one in English and one in elementary education. Okay? There are 3 levels of graduating college with honors. You can graduate cum laude, you can graduate magna cum laude, you can graduate summa cum laude. It's the 3 levels of honors at college. You get that based on the GPA that you had. GPA is out of 4. I had a GPA of about 3.7 and change, so I graduated magna cum laude, the second one. My wife graduated with a 3.96. Yeah, she was summa cum laude. She's much smarter than I am. But anyway, I digress. Back to this. This is standard form. This is the form that we've been familiar with. This is the form that we've worked with. This is the form that we've just used. A, B, and C. We've used A, B, and C to factor. We've used A, B, and C in the quad formula. And now you've seen A and B in the vertex formula. But I want to take it a bit farther. And then I'm going to show you something on Desmos. I want to show you something on Desmos after that. Vertex form. Vertex form. Now, vertex form, I don't know if Betty has already covered it, and that's fine if she has. We have not covered it. I'm just showing it here. Cool. Vertex form is still a quadratic, and I'm going to show you this on Desmos to show you that all three formulas do indeed give you the same thing looks like this. Now, there are some things that look familiar, and there are some things that don't look familiar in regards to the first equation. First of all, yes, it still has an x and y. Yay, it has an x and y. It still has an a. The a is the same value. What are the only letters that you're not fairly familiar with? H and K. You're like, what the heck are H and K? Well, it just so happens that H and K are the vertex. What I need you to be able to do is I need you to be able to see an equation and be like, oh, that's written in vertex form. And if it's written in vertex form, you can still try to graph this thing out. Now, in a little bit, I'm going to give you the following examples. Make sure this works properly. Yeah, I'll do 8. There we go. I'll do 8. Good. So I got y equals x squared plus 2x minus 8. Now, I'm going to graph that in a little bit in Desmos so you can see what it looks like. But if I were to calculate like a little vertex situation going on here, negative b, we get negative 1, plug that back in. You got 1 minus 2, just negative 1, negative 9. I would get a vertex of negative 1, negative 9. Thus, I believe that this should work out like this. There we go. Now, it looks completely different than the first equation. It looks completely different from the first equation, but I'm going to tell you that both of those equations actually are the exact same thing. They are the exact same thing. It's really nice, actually. But we'll deal with that in a little bit. I'll leave that up there, and I'm going to write one more form. One more form that I have not talked about, but you should be very familiar with. It's called intercept form. Intercept form. Now, intercept form is nice. Intercept form is actually really cool. Intercept form looks like this. And you're like, what the crap? But you've seen that before. You have seen that in this class. Not today, but you've seen this. We have spent a good deal of class periods factoring by whatever method you want. And when you end up factoring, you end up getting these two sets of parentheses being multiplied together. This is also known as factored form. Because if you just take a quadratic and you factor it, then you have intercept form automatically. You've seen that on various assessments. You've seen it. You just don't know that you've seen it. If I were to take this, and if I were to factor it, I believe it would look something like this. Because I have two magic numbers that multiply to -8 and add up to +2. All three of those equations say the exact same thing. P and Q, by the way, P and Q, the letters that you're not familiar with, they just end up being your x-intercepts, which is why they call it intercept form, because we would factor and we would get our x-intercepts. Our x-intercepts here would be -4 and +2. You guys ever hear the phrase, mind your P's and Q's? Has anyone ever heard that before? You have? Do you know what it means? When people say mind your P's and Q's, it typically means to like mind your manners or mind the details or something like that. It came from the printing press. The printing press, you know how I don't know if you know how the printing press works. Basically, put a bunch of like block letters on a thing, put some ink on it, and then you like press a piece of paper onto it. But the block letters are backwards. And lowercase p and lowercase q look very similar, especially when they're backwards. So the printing press operator was told, hey, mind your P's and Q's. That has nothing to do with anything. I just wanted to share that. So let's go to Desmos. Desmos. I'm going to put 3 equations up here. First, I'm going to put y equals x squared plus, what did I say, 2x minus 8. And it's in red. Next, check this out. What do you notice about that blue equation? What do you notice about that blue equation? Look, there's the first one. There's the one in red, the first equation. Here's the second equation in blue. What do you notice? They're the same. They're right on top of each other. Here, third equation. It's going to be in green, I think. Y equals parentheses x plus 4, x minus 2. Right on top of each other. Insane. All 3 of those equations are saying the exact same thing. They're saying the exact same thing. Oh, it's going to be amazing. Now, as I said, next week, I do plan on having an assessment on all of quadratics. A lot of the stuff that we've been focusing on, which has been factoring and quad formula. I've graded the A-Day class periods projects. They should be ready to go with whatever appropriate feedback you have. If you do have any questions in regards to that project, please make sure you're emailing me separately. Is he still out in the hallway? Can you see if anyone's still there? Is he still there? All right, cool. He was standing there for a long time, right? Yeah. That was weird. I don't like that. I don't like people looking at me all the time. Gosh. Anyway, whatever. One time I was being observed by a principal, not Mr. Nickel, the principal who was here before, Mr. Nickel. I was being observed by him, and he observed me the Thursday of Christmas break. Like, it was like Thursday, and then Friday was a half day, and then it was Christmas break. Yeah, and he observed me on a Thursday, and I'm with a class that at the time it was a HESPA prep class, where it wasn't even a real class. It was just basically like an elective class where they like prepared to take the HESPA, which was the state test at the time. And he's sitting there observing me, and I had not planned to do anything that day. I had literally planned to like play games with them. And he comes in, and I looked at the kids, and these are all like 11th grade kids who like, they're not really great at math. They don't want to be here. And I looked at them, and they looked at me, and we all had this like kind of like telekinesis moment where in my head I looked at them, and they all heard me say, "All right, guys, just bear with me for a little bit. We'll get through this together." And they all did it. And I taught some garbage lesson for 15 minutes, and then the principal had to leave. He had to leave because it was Christmas time. He was wearing a Santa tie that if you bumped it on the right spot, it would sing a song, a Christmas theme song. And he kept on bumping it like every few minutes, and it kept on interrupting. And I think he realized he was being a disruption, so he left. Like, oh, it's great. And then we played games. What a day to be alive. Anyway, the last thing I'll remind you of is the benchmark. Several of you have actually already taken the benchmark. Believe it or not, I've assigned it yesterday. Like 5 people have already taken it. I don't know, it's weird. But please make sure you're jumping on top of that. It's going to be great. Yay. Anyway, I'm going to sign off, and we'll call that a day. Woo!